Moving right along, question number 24 asks about the sample size to estimate a proportion. So pull out the formula for sample size for a proportion, which looks like this. The p hat is the proportion for the previous study, 32% or 0.32. The q hat is 1 minus that, so 0.68. The z sub alpha over 2 for a 95% confidence level would be 1.96. And the E, the margin of error, well, we want to be accurate to within 5%. But make sure you don't put in the number 5 for E. E is not 5, it's 5%, which would be 0.05. So when you calculate this, 0.32 times 0.68 times 1.96 over 0.05 squared, you get 334 point something, and when you round that up to the next whole number, you get 335. So that means they need a sample with at least 335 people in it. 25 asks for a confidence interval for population standard deviation. So this is the kind of formula for that. And to use this formula, we are going to have to look up the values for chi-square right and chi-square left on table G. We're doing a 95% confidence level, so we are going to look in the columns labeled 0.025 and 0.975. And the sample size is 20, so the degrees of freedom would be 19. So on table G, we're looking in the 0.025 and the 0.975 columns with 19 degrees of freedom. So the numbers are 8.907, well, I guess I should start with 32.852 and then 8.907. So those go down in the denominators of these expressions. The n-1 is 19, the standard deviation is 107, and that gets squared as a part of the formula. And when you calculate this out, it comes to 81 to 156. Now we come to the stuff that you have not been tested on yet. Up until this point, all the problems we've been going over have been similar to things that you've seen before on one of the tests we've already had. But now we come to the problems involving chapters 8, 9, and 10, hypothesis testing and correlation and regression. There will definitely be plenty of this stuff on the final exam because I want to make sure you know it and we haven't been tested on it yet. So, it has been reported that the average worker in a particular industry makes $10.50 an hour. A researcher randomly selects a sample of 25 workers in his area and finds that the workers in this sample earn a mean wage of $9.80 with a sample standard deviation of 70 cents. Is there reason to believe that the average hourly wage of workers in this area is different from the reported average of $10.50? Use alpha equals 0.05. So this hypothesis testing is a 5-step process. Step 1, figure out what the claim is that you are testing and state the null and alternative hypotheses. So pay attention to the wording for what the claim is. Here the claim is that the average hourly wage of workers in this area is different from the reported average of $10.50. Different from would mean not equal to. So you would write that as mu, the average or mean, is not equal to $10.50. Now, because that does not have an equal sign in it, instead it has a not equal to sign, that is the alternative hypothesis. The null hypothesis is the same thing, but with an equal sign. So the null hypothesis and the alternative hypothesis are always going to be the same as each other, except that the null hypothesis always has an equal sign, and the alternative hypothesis does not. It has either a less than, or a greater than, or a does not equal, depending on what claim you're actually testing. Now, we are told that the sample mean is 980, and the sample standard deviation, so that would be S, is 0.70, and it's a sample of 25 workers, so that's N, that's the sample size. On the test, well, the way I've tested this in the past, some people have had graphing calculators and some have not, and to make it fair, I just didn't make you calculate things like the test statistic or the p-value, but I did make you write down all the things that you would need to put into a graphing calculator or the Excel spreadsheet or something like that to get the p-value. So here, I want to make sure you know what the x bar and the mu and the s and the n would all be to calculate those things. So x bar is 9.80, mu, the number from the hypotheses, is 10.50, s is 0.70, and n is 25. We are doing a t-test for the mean, and it's a t-test because we don't know the population standard deviation, just the sample standard deviation. Now, if you calculate the test statistic from those numbers, it should come out to be -5, and then the p-value turns out to be 0.00004. Now, in step 4, you have to decide whether you reject the null hypothesis or do not reject the null hypothesis. It has to be one or the other of those. So in step 4, you compare the p-value to the level of significance, the alpha. Here, the p-value is a lot smaller than alpha. 0.00 something is less than 0.05. So with a small p-value, one that's smaller than alpha, that's when you reject the null hypothesis. Now for step 5, if we did not reject the null hypothesis, that would mean that there is not enough evidence to blah, 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 blah. But we did reject the null hypothesis, so we do have enough evidence. Enough evidence for what? Well, what was the claim? The claim, remember, was the alternative hypothesis. Now, we just said reject the null hypothesis. If we're ruling out the null hypothesis, we must be supporting the alternative hypothesis. So that means we do have sufficient evidence to support the claim, to believe that the average hourly wage in this area is indeed different from 1050. Number 28. You want to buy a vacuum cleaner and a salesperson tells you that the repair costs for Model A are less on the average than for Model B. Notice what this claim is. It's a claim about two different averages, that one average is less than another one. Mu1 is less than mu2. So because it's got a less than, that makes it the alternative hypothesis, and the null hypothesis would be the same thing but with an equal sign. Mu1 is equal to mu2. And this is the kind of situation where we are comparing two different population means. We do know population standard deviation, so this is a z-test, but it's a z-test for 2 population means. The numbers we would have to use to calculate the test statistic are the sample means for the 2 different samples. The Model A had a sample mean of $50, and the Model B had a sample mean, an average repair cost for the ones in the sample of $54. So that's your X bars, 1 and 2. The standard deviations are $10 for Model A and $12 for Model B. So that's your sigmas 1 and 2. The sample sizes are 30 and 35. And so on the test, I would just give you the test statistic that's calculated from these. But if you had to find it yourself, you would either use the graphing calculator function and put in these numbers. You'd pull up that Excel spreadsheet and put in all these numbers. You'd put all these numbers into the formula that we looked at in section 9.1 or something like that. Then the p-value I will also give you. It's the kind of thing that the graphing calculator or the Excel spreadsheet or something like that could tell you. And here it turns out to be 0.0714. Now that is greater than 0.05. The p-value here is greater than the level of significance. So when we have a big p-value, when it's bigger than the level of significance, that's when we say do not reject the null hypothesis. And then since we said do not, there is not, remember not goes with not, do not reject, so there is not enough evidence to, well, what was the claim? The claim was the alternative hypothesis. We talked about not rejecting the null, so that means not supporting the alternative. There is not enough evidence to support the claim that the repair costs for Model A are less on the average than for Model B. 29, I just asked you to look at this scatter plot and tell whether it looks like there's a strong positive relationship or a strong negative relationship or neither one of those between the 2 variables. When I look at these data points, these dots that make up the scatter plot, they look like they line up not perfectly but pretty well in a line that's going down as you go from left to right. So it looks like the bigger x's go with the smaller y values and the smaller x's go with the bigger y values. If you did draw a line, it would have a negative slope. So that looks like we have a negative relationship between the variables. And I'm going to end this video here and come back in the next part and talk about the correlation and regression involved in the next set of problems or the next multi-part problem.